Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with water supply engineering in the topic of conduit for transporting water. So the problem is estimate roughly the size of supply conduits leading to an adequate service reservoir serving a first one is relatively small town of 25,000 population. Okay, so the second one is relatively large city with the industrial establishment having the population of 5 lakh people. Okay, so we have to find out in both cases the small town as well as the large city. Also find the hydraulic gradient at which the pipelines are proposed to be laid. Assume the suitable data according to the IS were required. Okay, so now first thing is we have to find assume that. So now we have to assume the what daily demand. So demand for first thing is for small city. So small city we assume the daily demand is 120 liters per capita per day. Okay, so for large city in industrial population, so we can assume the 270 liters per capita per day. Okay, so these are all the assumptions. So now the solution. So first thing is quantity of water. So quantity of water required. So for small city. Okay, so now we can take the population of population into daily demand. So the population is 25,000 into demand is 120 liters per capita per day. Okay, so now we got the value of 3 million liters per day. Okay, so now the quantity of water for large city. So same as population is 5 lakhs into average daily demand is 270 liters per capita per day. So solving this we got the value of 135 million liters per day. So now we can assume that maximum daily demand is 1.8 times the average. So these are all the average demand per day. So if case some days the demand will be high and some days the demand will be low. So these are all the average. So now we have to supply the peak demand. Okay, now we have to design the conduits for peak demand. So now we can assume that 1.8 times the average demand. Okay, for example, take as a Sunday, the consumption is more. Okay, so take the small city. In the small city, the Sunday consumption is more. If case we can take the industrial establishment 135 liters million liters per day. If case in the day is Sunday, the consumption will be low because of the every industry is on leave on Sundays. So the consumption is relatively low. So likewise we have to find out the daily maximum demand using average. So now assume the maximum daily demand as 1.8 times the average demand. So now the first one is small city. So small city 3 into 1.8 liters. Okay, so now we got the value of 5.4 million liters per day. Okay, so now we can convert into meter cube into per second. So now we can take 5.4 into 10 power 6 divided by, we can convert into meter cube. So 10 power 3 into this is for day. So we can convert into seconds. So 24 into 60 minutes into 60 seconds. Okay, so now solving this we got the value of 0.063 meter cube per second. Okay, so likewise we can convert into large cities. So now the large city. So now 135 into 1.8. Okay, so now 135 into 1.8 we got the value of 243 million liters per day. So now we can convert into 243 into 10 power 6 million liters. So divided by we can convert into meter cube. So now 10 power 3 into 24 into 60 into 60. Now we got the value of 2.81 meter cube per second. Okay, so now we found out the quantity of water. So Q is we found out. So next thing is we have to find out the area of the conduit. So the diameter of the conduit is the first question answer. Okay. So now we can assume v velocity is 1.2 meter per second. So this is assumptions. So now we can take q equal to a into v. Okay, so now the q is 0.063 meter cube equal to the area is we have to find out into velocity is 1.2 meter per second. Okay, so now solving this, we got the value of a 0.0525 meter square. Okay, so likewise we can calculate for large cities. Now 2.81 equal to area into 1.2. So now the area will be 2.36 meter square. Okay, so from that we can find out the diameter. We can convert the area equal to 525 centimeter square. So now from that we can find out the diameter. So now area equal to pi by 4 into d square. Okay, so now we can substitute 525 as area. So now we got the value of diameter is 24.9 centimeter. Okay, so this is the conduit diameter for small town. So area equal to pi by 4 into d square. Now we can substitute 2.36 as a area. So now diameter, we found out the diameter as 1.74 meter. Okay, so this is the diameter of the conduits. So next thing is hydraulic gradient. So for the hydraulic gradient we can use the Hazen-Williams formula. So the Hazen-Williams formula, V equal to 0.85 CH into R power 0.63 into S power 0.54. Okay, so now we can assume the CH value is 110. Okay, so now we can substitute all the values over here. So now so 0.85 into 110 into R is d by 4 whole power 0.63 into S power 0.54. Okay, so now solving this we got the value of 93.5 into d divided by 4 power 0.63 into S power 0.54 equal to V. Okay, so now we can find out for small town. So small town, the V value is 1.2 equal to 93.5 into D is we found out in centimeter. So we can substitute in meter. So that is 0.249 divided by 4 power 0.63 into S power 0.54. Okay, so here the only unknown is S. So now solving this we got the value of S equal to 1 by 125. Okay, so this is the hydraulic gradient for small city, that is 1 meter in 125 meter length. Okay, so likewise we can calculate for the large town. So now we can substitute 1.2 into 93.5 into here D is 1.74 divided by 4 whole power 0.63 into S power 0.54. Okay, so now solving this we got the value of 1 by 1260. Okay, so now the hydraulic gradient is 1 meter in 1260 meter length. Okay, so this is a method we can solve the problem. Again we will see next video. Thank you.